Hello, welcome back. Here we have the review. We're in Chapter 5 Review, Algebra 2. We have problem number 19. We have this cubic function, x to the third minus 7x plus 6, and we're meant to graph it. First thing you'll want to do, of course, is to figure out how the actual function factors down. So I'm going to rewrite it over here on the right where there's some room. And then realize that since it's not quadratic, I can't use the quadratic formula. And since it's cubic and above, I'm pretty much stuck using the rational root theorem, trying to find numbers that I should bother trying. The constant term is 6. The leading coefficient term is 1. So if I were to make a list of possible zeros, that is, things I should bother trying, I'm talking about factors of 6 over 1. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. That's a list of 8 numbers that are worth trying. So let's try them. A lot of these numbers may not work out as zeros, but they might be values that we would want to substitute into our function anyway. So I always kind of start with 1 because 1 is the easiest number to work with. And if you do direct substitution with 1, you find that the answer is 0. That should make you feel pretty happy, right? So we have the point 1, 0, and we know that the polynomial factors, it's x minus 1 times, something. We don't know what that something is yet. So to do that, we need to do the some sort of division. You could use polynomial long division. Most people prefer to use synthetic division. So I'll show that. Now notice that I included the 0. That's because there's a missing x squared term. So if you bring down the 1, multiply by 1, add 1, bring down the 1, multiply by 1, you get negative 6 times 1 is negative 6, and you get 0. And that's good news, because we thought that was going to work out. So we have, we have g of x equals, we had x minus 1 as the factor, and then x squared plus x minus 6. That's wonderful news. Now, of course, before I go farther, those numbers came from the end of the synthetic division. Now, back to the wonderful news. It's wonderful news because that's really easy to factor, at least as far as anything could possibly be easy to factor, because that makes x plus 3 x minus 2. So boom, we are totally in business, right? We know the zeros, the actual zeros, are at x equals 1, x equals negative 3, and x equals 2. Each of those comes from the factors. I got excited and graphed the first 0 already because, well, it's nice to feel like you've made progress. But now I can go ahead and graph the other zeros. So at 2, there's a 0, and at negative 3, there's a 0. Now, this is just marvelous. We're totally on our way. Now, you might at this point need to find some other values, though. So let's talk. Since negative 3 is the first 0, oops, I lost it. Sorry about that. There we go. Since negative 3 is the first 0, I'm going to substitute in negative 4 also, just to see what I get into the equation. And that makes negative 30. Now that's nice and all, I suppose. It's simply not going to be something I can graph. Now, I'm not going to do negative 3. I already know that one. But maybe negative 2, and that gives me 12. Now you might originally say, or excuse me, you might initially say that 12 is no good, but if you check out the y scale, you see that it's scaled by 2's, so 2, 4, 6, 8, 10. 12 is right there, although the x value was negative 2. So we have negative 2 comma 12. And we carry on. F of negative 1 is 12 as well. Interesting. So we've got negative 1, 12. Okay. Let's see here. F of 0, we probably need to know what that is. F of 0 is 6. So 2, 4, f of 0 is 6. Remember that y axis is scaled by 2's. F of 1 we know. F of 2 we know. Those were both zeros to begin with. Probably finish up, at least, and see what f of 3 is. F of 3 is 12. This does seem to be a common output for some reason in this function, but no matter. Easy enough to graph. Boom. We've got some dots. Now, before we get all excited and fill it in, I do want to talk about end behavior. So I'm going to make a little note at the bottom. Now, when you're doing this on the test or whatnot, you don't necessarily have to show all this stuff, but since you were watching, I thought I'd make sure we talked about it. It is an odd degree polynomial, right? Because it's to the third power. So it's an odd degree polynomial, and it has a positive leading coefficient. And it has a positive leading coefficient because the leading coefficient is the 1, okay, the invisible 1 in front of the x to the third. Together, both those things mean that the end behavior arrows are going to be like that. It's going to go to negative infinity when x goes to negative infinity, and the function will go to positive infinity as x goes to positive infinity. Well, here we are. We're ready to graph. So, on the left, and then pretty much just need to connect the dots smoothly so it turns around somewhere in there. You know, maybe in the middle, maybe not. Don't know how high it goes. Don't really care. Could use calculus to figure it out, but you know, that's not what we're doing here, which is just fine. So we go up. Our arrows match the direction. We've gone through the zeros. Each of the zeros comes from a single factor, so our graph should pass straight through each of the zeros and kind of turn around in the middle on the way around. We've got our arrow set up. We're done. Thank you for watching.